Welcome. Today we're going to be talking about securing bare metal using a service mesh. The first steps in this deployment is going to be deploying the physical infrastructure that's going to be running the microservices we're going to protect, as well as the service mesh itself. So our sample microservice is a fortune cookie service. It's just you connect to port 8181 and it replies back with a fortune. It's unencrypted, so because of this, the traffic can be seen by everyone. The infrastructure we're deploying, we're going to deploy 3 physical machines. That's going to make up our service mesh itself. And then initially we're going to deploy one microservice, which is going to be the fortune cookie service itself. And then a second physical machine, which is going to be the fortune cookie consumer. So it's going to consume the microservice. We're using Terraform to deploy the infrastructure. So as you see here, it's going through and deploying the 5 physical machines, the 3 Consul service mesh physical servers. So in Terraform here, we're using a plugin that connects to the Packet bare metal cloud. So it's a public cloud that provides physical resources, so physical servers. We're using the smallest infrastructure, just the t1.small.x86, and running the Ubuntu operating system on them. So Terraform has gone and processed our Terraform files, taken a look at what needs to be built, and then Terraform is connecting through the plugin to the API on the Packet side and requesting that those machines get spun up. So in parallel, all 5 machines are going to get spun up. So as we see here, it's going through, just waiting for those physical machines to be spun up. So there we see that they've been spun up, turned on, and then it's just going through and installing the requested software that we wanted on it. So that would consist of the service mesh software itself, so HashiCorp Consul, and Fortune, and then setting up that service to be running, and then copying over some configuration files that we have to set up the service mesh and to set up the fortune cookie service. Going back to the fortune cookie service, as you can see there on the earlier snapshot of the GitHub pages, it shows a sample where we run TCP dump, and TCP dump goes through, and it can see the request going through across the wire. So typically you wouldn't want traffic to be visible across the wire, you want it to be encrypted. So in this example here, we're showing how we can take a service, a microservice, and layer on top of it encryption and authentication so that the data in motion is encrypted and authenticated so that we don't have to trust the underlying infrastructure. So Terraform's completed. Our 5 machines have been spun up. So that took just a couple of minutes there to spin up all the infrastructure. So as you can see, there's the 3 Consul servers. Those make up the service mesh, and then we just pinged the fortune cookie servers. And then right now we're just making some netcat connection support 8181 to show that yes, indeed it is returning back a fortune. Just to verify our hardware, we're going to connect into the Packet bare metal clouds, their GUI. So just to go through and take a look at the hardware that's been deployed, we're just typing in our 2-factor authentication token. Don't worry, the 2-factor authentication tokens are only valid a certain amount of time. So by the time this is posted on YouTube, that token is no longer valid. So there we can see there's the 3 physical machines, the 3 Consul machines and the 2 additional fortune cookie machines. So each of them has been set up with public IPv4 address, IPv6 address, and then a private IPv4 address. That private address is only usable within the Packet data center within the project there. So only those 5 machines can access those private IPv4 addresses. So we're just taking a look at one of the service mesh file servers, the Consul 00. There are 3 of them, Consul 00, 01, and 02. They're all identical. Packet does provide out-of-band console access, so if you screw up the networking, you can connect in over SSH to a terminal server and log in on the console. Okay, so our physical infrastructure has been deployed. Let's go ahead. We're going to take our 3 physical machines and we're going to spin up the service mesh and get the service mesh fully joined. As I explained, we have 3 physical machines, Consul 0001 and 02, each of them with 3 IP addresses, IPv4, public, private, and IPv6. We're not going to use the IPv6 address in this. We are going to use the v4 address, the public and the private addresses there. So first thing we need to do is start up the Consul agent. So the Consul agent can be run in both client and server mode. It takes a couple of parameters, including which IP address you want it to bind to. In our case, we're going to bind to the private IPv4 address. So we're going to start it up. And the first one, we're going to start up in a bootstrap mode. This is how you start up the first machine in a cluster environment. We're just going to basically tell the Consul server that, hey, you're the first one. Don't panic when you don't see any other machines when you start up here. So the first one started up. And now we're going to switch over to the Consul 01. We're going to start up that machine, and then we're going to join all 3 of these machines together into one cluster. It's going to run in an active, passive mode. So one of them will be elected a leader using the Raft protocol. If you're familiar with Ceph, it's the same idea. So let's see, we've got that machine. Consul 01, the Consul agent is now running. Now we're going to join it to the first one. So we're going to have to give it the IP address to the first one so it connects on. And you can give it the IP address to any of them that are running, and it'll forward it on to the leader. So our Consul 01 is now joined with Consul 00. So we've got 2 machines making up our cluster so far. We can go through and output a list of everything that's running. So we can see we've got 2 servers running. The Consul binary, the agent, can be run in either client or server mode. The first 3 that we're starting up, we're going to start them up in server mode, and then we're also going to run it in agent mode on the machines that are going to be running the microservices. So Consul 02, we're joining that. We're going to use the IP address of Consul 01, the private IP address, because remember we bound to that private IP address port. So it's joined in. Now notice that you actually saw the message popped up on Consul 00. That's because Consul 00 is the leader. So Consul 01 forwarded the request from 02 to 00, told it to talk to 00. So we see that all 3 are running. We can go through, take a look at how the Raft protocol did electing a leader, and we can see that 00 is running as the leader. Now we're going to go back and restart 00 as in non-bootstrap mode, so just regular mode. Then the leader election is going to be rerun because the leader, we killed it. So it'll go through and it's gone and elected a new leader. So as we go back, now that it's all 3 of them are running again, we can say, hey, who's the leader now? And we can see that 01 is now the leader. So at this point, we have our 3 Consul servers running. They are responsible for registration of maintaining the registration of all the services we're running. So now we're going to take our fortune cookie service, and we're going to take that server, we're going to join it in as an agent and register it into the service mesh. So remember, our fortune cookie server runs on port 8181. Right now it's an unsecure protocol. It's anyone can connect to port 8181 and request a fortune. Anyone can listen to the traffic. So let's go ahead. We're starting up the agent. As you can see, we're running the agent in client mode as opposed to server mode. If you take a look at the configuration file, you can see in the configuration file on the left, which is the fortune cookie server, where it says server false. That is telling Consul when you run the agent on this machine, do not run it as a server. On the right is our Consul 00 server. You can see where it says server is true in the configuration file. That's telling it when the agent is run on that machine that it should be a server. So just a slight difference. Same binary, just we're running it with a different configuration file, and that's how it knows what mode to run it in. Next on our list is we're going to start up the agent. So the agent is started up. And then we're going to need to go and join it in to the mesh. So it's going to need to know the IP address of one of the Consul servers. And so we pull that off of the Consul 00, and now we will join the we will join it in with the rest. So we're connecting into it. We just wanted, in the first upper left-hand window, we just want to get the output going so we can see how it goes through and it displays that it's connecting on. So as you can see now that service is registered, you see it says synced service fortune. We can list all the members that make up the service mesh are now our fortune cookie server. That FCS00 is now connected into the mesh. It's running as a client. The data center column there, DC1, we're just running a single data center. So we're just using the default DC1 name there. Okay, so now we're connecting to the fortune cookie consumer. So that's FCC00. And same thing there, we're going to start up the agent much like we did with the fortune cookie server, and we're going to connect it in to the mesh. Okay, we're going to give it the IP address of the server, and then the fortune cookie consumer is now joined. As we go through and list all of the members, we can see that now FCC00 is connected on to the mesh as a client. In this example, for right now, we're just running a single consumer and single client, consumer. So we're just going through, list out the data centers. Like I explained, we have a single data center. We're going to go through the catalog and list out all the nodes and all the services that are running. Right now, we're running two services, the Consul server itself, and then the Fortune service in an unencrypted mode. And we can also go through and list across all of our physical machines what services are running across each physical node. So we can see where the Consul service is running and then where the Fortune service is. So now we're going to go through and we're going to take our Fortune cookie server and we're going to secure it. So we're going to register it with the service mesh. We're going to tell the service mesh where it's running, and we're going to start up a sidecar. So the sidecar is responsible for connecting and consuming the unencrypted traffic, but then taking that data and piping it across the wire in using TLS encryption across the wire. So in order to do this, we are going to go through and we're going to turn off the regular unencrypted Fortune cookie service running on port 8181 and replace it with a new Fortune cookie service that is going to be secured and running through the sidecar. So there we're just going through verifying that yes, the Fortune cookie service is running on port 8181. So our two configuration files, we've got secure service and then the regular service. They differ in the secure one has got the additional sidecar service, and that sidecar process is responsible for handling all the encryption and authentication. So we're going to remove the regular service, the JSON file that describes that service, and then we're going to copy over the secure one into the Consul configuration directory. And then we're going to tell Consul to go and Consul on this server, the Fortune cookie service, to go through and reread all of its configuration files. So right now it hasn't rewritten yet, so we're just going to go through and say what's running, and now we reload it. It's reprocess the configuration files, and now we have this registered Fortune. The sidecar proxy is now registered. It's not actually started up, so we're manually going to go through just for the sake of just for an educational process. We're going to go through and manually start up the sidecar proxy to see what's that all about and what's involved there. So like I said, the sidecar proxy, we're going to run it on port 9191. It's going to be responsible for taking inbound connections, authenticating them, handling the encryption, and then making a request to the service itself that's running on port 8181 and retrieving the data and then piping it back across the network. At this point, we have not disabled the unsecure one. It is still listening on all the ports. So later on, we'll go through and disable that. So far, we've turned on the sidecar on the left. And on the right, we are now going to the Fortune Cookie consumer, and we're doing the same sort of thing. We're starting at the sidecar to consume the process. So that way, whatever process is running on the Fortune Cookie consuming machine can then go and make a request on that port and consume the get the fortune, but going through the secure channel. So now we should be able to go through. Yeah, we can see it's bound to port 9191 on the local host. So if we connect to 9191, we can see that, yep, we've now been able to go through and get a fortune going through. So it'll go Fortune Cookie server, port 9191, will connect on to Fortune Cookies, the Fortune Cookie service, port 9191, and then it'll connect on to 8181, the unsecure one. So as we go through, we can see, as we go through and make the connection, we see it popped up on the console of the actual Fortune Cookie service. Those additional ones that are popping up when we're not making a request, those aren't just ghost ones and random people on the internet making connections. They could be, but they're most likely just the health check. So Consul continuously goes through and validates that the service is running correctly. If it is running correctly, it'll leave it in the registry. If it is not running correctly, there's no response, the socket's closed, it'll go ahead and remove that node, so in our case, the physical machine, from the service. And we'll get to that in a little bit later when we talk about scaling up and handling some failures. We'll actually go ahead and do that. Okay, so now keep in mind that our Fortune Cookie service is bound to all ports. So what that means is the IPv4, IPv6, every single interface it is bound to and receiving and accepting connections. So what we want to do is we want to turn that off, and we only want to connect to the loopback, to the local host address. So what this means is the Fortune Cookie service, the unencrypted one, will only accept connections from the local host machine. So it won't receive connections across the wire, across the internet, which will essentially lock down the unsecure version from people connecting to it. And the only people that would be able to connect to it would be processes running on that physical machine, and the sidecar runs on that physical machine. So the sidecar would then handle encryption, authentication, and then passing connection on. Okay, so we talked about this a little bit. We talked about scaling up. So we're actually going to go through now. We're going to go through and we are going to scale up the number of Fortune Cookie servers we have. We're actually going to scale up additional physical machines. So we're going to run through our Terraform configuration file. We're going to take a look at the variable setting we have for the Fortune Cookie service count. So that's the number of physical machines we want to run. We're going to up it to 3. We're going to run Terraform, and then Terraform is going to take a look at our desired state, and then spin up the additional machines. We're just doing some extra steps here to have Consul automatically start up. Previously, we turned that off so that we could manually go through, but we're enabling it back on so Consul will automatically join in to the IP address of the first Consul server. Just eliminates some additional steps that we need to do. We're also going to update the script that's used to start up Consul. That was previously set up to so the Consul didn't start up, so we could manually just go and show you how things started up by hand. But in a real world, obviously, you'd want to have things automated, so we're turning that automation back on. So Terraform has gone through and seen, hey, we need to start up some additional machines, so it is starting up Fortune Cookie Service .1 and Fortune Cookie Service .2. So Fortune Cookie Server .0 obviously is already running, so we're going to start up 2 machines. So as I explained before, Terraform has a plugin architecture, so it's calling the packet plugin, and then that packet plugin Go code is then calling the packet API, is making a request for those physical machines, and then those physical machines are spinning up. The additional software that we need. So we'll do some apt-gets and install the fortune cookie binaries, and we'll install the Consul server software and run it in client mode, and it'll automatically join in to the rest of our mesh. So as we keep on going through and running Consul members, once it gets to the very end, we'll see fortune cookie server 01 and fortune cookie server 02 turned on. All those fortune cookie servers are identical. Obviously, they'll return different random fortunes, but otherwise they're identical, and that service can be just considered, just connect to whichever one you want and whichever one it is running, and the service mesh will do that for us. It'll track them all. Using the service mesh to find the physical machines that are running in this case, the Consul provides DNS lookups, API lookups. You can run the command line. There's a GUI. There's a bunch of different ways to go through and find out the services. Recently, someone asked me, "Hey, what do you do if you're running this across different regions and you want to make sure the requests go to whichever region you want?" Well, obviously, then you would use the data center portion feature within Consul and split up. So, okay, so our physical machines has been spun up. That was pretty quick. So if you take a look at the output of on the left, we can see that we've got 3 IP addresses now for the fortune cookie server. And then you can see that the Consul members now gives us 3 IP addresses. So we're going to do a netcat, go through all the IP addresses. Why did that first one fail? That's a little pop quiz there. Well, that's because we turned off the binding to all IP addresses, and it only binds to now the local host. So the only way on fortune cookie server 00 to connect in is on port 9191, where you need to be doing encryption. The fortune cookie server 01 and 02, we haven't turned on the encrypted services yet, so those two are still running in unencrypted mode. So we're going to go through, remove the JSON file that describes the unencrypted service, replace it with the JSON file that describes the encrypted service, restart Consul, do the same thing on fortune cookie server 02, and that'll bring online the all 3 of the fortune cookie servers. And then we can have some fun and start tearing all this down and making sure that the redundancy actually works. So all of this, all of the code and all the Terraform files and everything is all up in GitHub. So if you're feeling adventurous and you want to give this a try, you're welcome to download everything and spin it up. And all you'll need is your own account on Packet. The machines cost, I think, 7 cents an hour each. So you're looking at, 1, 2, 3, 4, 5, 6, 7 machines. So it's 50 cents an hour to go through and run this demo. But it's worthwhile to do things on physical machines from time to time. Obviously, this is the same thing will work on a VM, so you could use Amazon as well if you wanted to. Okay, so we've gone through, and we are starting up the Fortune service. We rebound it, so it's no longer bound to all IP addresses. It's only bound to the loopback. Doing the same thing on the 3rd fortune cookie service, binding it to the loopback. So sometimes I don't type things perfectly. So. Okay, so we got everything running. We got it unbound. It should be secure now. We can't connect to it on the unsecure port, which is great. So we're going to go through, verify everything's running correctly, make some requests. Oh, first we got to start up the sidecar proxies for all of those, and then once all the sidecar proxies are started up, we can start going through and killing things and making sure our redundancy works. Okay, so our proxy started up on number 01, proxy started up on number 02. So the Fortune sidecar proxy is listed. Okay, so now from the Fortune cookie consumer, we're going to make some requests, and you can see we're getting responses back. Obviously, we don't know right offhand which machine, which Fortune cookie consumer or server is responding to us. But what we can start doing is we can start going through and shutting machines down. So these are physical machines. We're just going to do a shutdown halt. So that'll bring down the Fortune cookie server 00. So we're down to 2 of the 3 are still running. Okay. So our service is still running through the service mesh. The service mesh has detected that the one machine is down for the health checks. And now we're going to connect into the Fortune cookie server 01. And we're going to do the same thing. We're going to shut it down. So now we're down to 1 of 3 running. So the health check takes a second or two before it realizes, which machines are down and that machine is down. So this one might fail, and then we're going to just run it again, but now we're running just fine on 1 of the 3. And then obviously if you go and you connect to the 3rd machine and kill it, we should have no responses back from anything. Okay, so at this point, the service mesh really can't do anything because all the services are down. So the goal of all of this is, like I said, we've taken a application, the Fortune cookie service, and we have gone through and secured it without having to change the application itself, without having to go back to the development team that wrote that application and asking them to add in encryption or add in authentication. None of that is required using a service mesh. We've simply added on without having to go through a development cycle. So that makes life a lot easier for internally. And then we've gone through and we've illustrated how we can improve service resilience as well through service mesh. So thanks for joining me here. And like all the YouTubers say, if you enjoyed this, please hit the thumbs up like button.